I apologize for that because I haven't really taught online for a number of years after COVID, so everything had to be in person. So for some reason, I forgot to record it, except for today. Today have to be on Zoom, and so we need to find a conjugate for 4 minus 5 minus 4i, right? So we can either change the sign for the first term, so second term doesn't matter, but you just only change one of them. So that equivalent to 5 plus 4i, correct?
Hmm.
And then we just multiply by the numerators and denominator by 5 plus 4i. So multiply both numerators and denominator by 5 plus 4i. And then we're going to simplify it further. So the fractions that we have here, so the whole fraction that we have over here, so we need to expand it, correct? We need to expand it, right? So we have to expand the numerators and denominator. Anyone can help? So we have the 2 times 5 is 10, and then this, and last, correct? So we do the same thing for this as well, like 5 times 5 times positive 4i, and negative 4i times positive 4i. So it turns out to be 10 plus
8.
8i plus 59 plus 12i squared. Okay. So the denominator will be 25 plus 20i minus 20i minus 16i squared. And then we can simplify further. So the 10, so that one is this. So 10 minus 12 is negative 2. So you're going to get the answers like that. Is that good, people?
Yeah.
So 10 minus 12. So this one's negative 12, right? This one's, so I squared is negative 1. So 12i squared is negative 12. Okay. The same thing for that. This one is positive 16. We add them up. Okay. And then we just cost out 20i. So 25 plus 16 is 41. And so 8i plus 15i is 23i. 10 minus 12 is negative 2. So now when it comes to the last part, which is I to the power 2025. So every multiple of 4 is 1, right? So every multiple of 4 for exponent is 1. So we have like I to the 4 is basically 1, right? Okay. I to the 8 also 1. I to the 12 is 1. So this one I to the 2024, I to the power 2025 is simply equivalent to, so 2025 is not divisible by 4, but we can get to the fraction. So we just take 2025 divided by 4. You got 2024, which is perfectly divisible by 4. Is 506. And then you multiply with I. So this one just simply give us the answers equal to I. Are we good? So the whole thing is turned to 1. Are we good?
Yes, thank you.
The same thing for that. This one is going to be I to the power I to the power of 400, because 400 is divisible by 4, right? The quotient is basically the quotient is 100 times I squared. So this one is just 1, right? So we have I squared is -1, so -8 times -1 is +8, right? So this one is just -1. Are we good?
Yes.
So we have like 12i plus 8. That's it. All right, so you're gonna see this question like that on the test, of course. The practice test should be very similar to the exam question. So let me just go to the second part. So we have to solve for v, correct? So the first thing we have to do, we're gonna subtract so we have to isolate the v, right? In this question, we need to solve for a single variable. So isolate the v by subtracting t to the third both sides. Are we good? And then we gotta divide both sides by t, and we get it done. So we minus t to the third. So we just subtract them both sides. And afterwards, we're gonna divide both sides by t. And then just cross them out. We get this. So it's not a really hard questions, but just making sure that people know how to do it on a test. Okay, so now we're going to move to the next questions. This one should be a little bit more interesting. So first of all, for these questions, we need to remove 5 first. We had to solving for x, right, for this problem. So we're going to subtract 5 both sides. Okay. After we subtract 5 both sides, going to get negative 10, less than negative 2x, less than negative 3. And then afterwards, we're going to divide both sides by negative 2. So when we divide both sides by negative 2 for this problem, what's happening for that? So let me just do that on the sites. Divide by negative 2. Okay. So we have to divide it by negative 2 on 3 sites here. And then we just cost out a term. So we're going to get this one was 5, right? And this one just 3 over 2. However, we have to switch the inequality. So the side just switch back to this one. So we have to switch the inequality. Are we good? This one's so hard to lecture on my computer because like I changed the pen for some reason, the app. So I should download the old version. And then you're gonna get 3 over 2. So have you switch that 3 over 2 less than the x, less than 5. So we might end up with 5 greater than x and greater than 3 over 2. Okay. In other words, we're going to have 3 over 2 less than x less than 5. For this problem, we're going to solve, we're going to set each term equal to 0. So we have to set 2x minus 3 equal to 0. And then you're solving for x. We're going to get x equal to 3 over 2. And the same thing for that. We're going to set 4 minus x is greater or equal to 0. And such that we're going to get x equal to 4. Afterwards, we're going to do the test point. Okay. Oops. So we're going to do the test point for that. So the test point going to be focused on 2 of them. 3 over 2 and 4. So you pick any point that you have between those two. I would say I would pick the point negative 2, 0. So I'm sorry, 0. And you can pick 0 if you want to. That's the easiest point we can pick. And then afterward, we can also pick you can also pick like 1, I'm sorry, not 1, 2 between 3 over 2 and 4. You can also pick the point 5. So that is greater than 4. and you plug that into the equation. So we're going to plug that in. So when x equal to 0, so we're going to plug that in. We're going to get 2 times 0 minus 3 over 4 minus 0. That's going to give us negative 3 over 4. So less than 0. The same thing that we're going to pick the point x equal to 2. So we're going to have, so 2 times 2 minus 3 over 4 minus 2. And then we just divide that. So we're going to get 4 minus 3 was 1. So we're going to get 1 over 2 is positive, right? And then we can also check another point when x equal to 4, x equal to 5. And then you're going to get is negative, right? Less than 0 for sure. So we can check them. So 2 times 5 was 10 minus 3 is 7. So 4 minus 5 negative 1. So you're going to get this one's negative, and this one's positive, and this one's negative. So what are we looking for? So the questions wants you have a pot greater than 0, wants to have positive, right? Look at those. It's those ones who have a positive numbers greater than 0. So we're going to choose the one that between 3 over 2, 4, right? So 3 over 2 can be inclusive, but we should not include 4 for the question because the 4 is actually in the denominator. So we have to exclude that part. So we're going to get 3 over 2. And then 4. So this one should be bracket. I'm sorry, parentheses, exclusive. All right, are we good? Why we have to exclude a point x equal to 4 because it's on the denominator, so we cannot include that part. We cannot include x equal to 4. All right, guys. So now we're going to move up to the next one. The question says the keyword for that would be perpendicular. So which means that we need to take the negative reciprocal, right? So we need to take a negative reciprocal in this case. Okay. So in other words, we need to solve for the equation. So we have 2x minus y equal to 5. And then you're going to solve for y first. So you're going to subtract 2x both sides. And then afterward, we're going to have a negative y equal to 5 minus 2x. And then we divide both sides by -1. So we're going to get this one equal to um, y equal to 2x minus 5. So apparently that the slope is basically m. The slope m is equal to 2, right? And 1 equal to 2. So the slope that we're looking for, you have to be taking a negative reciprocal. So we're going to take m equal to um, -1/2. Okay. And afterwards, we can just apply the point slope. Um, the point slope form is simply which is y minus y1 equal to m times x minus x1. So the point I'm going to use, so this one's going to be x, and this one's going to be y. So to plug that in, so y minus y1, so minus 1, so that'll be y plus 1 equal to -1/2 x minus 2. We can simplify that if you want to. If you want to simplify that, you're gonna get y plus 1. You can distribute that terms. So you might get y plus 1 equal to -1/2 of x plus 1 as well. And then, so the line should be y equal to -1/2 of x. So let me draw a line and then on decimal calculator. So the line that we have is, so we have a 2x minus y equal to 5. And then the point that we have is 2 and -1. So we're going to label that. They're actually on a line. That's kind of weird. And then they're also perpendicular to the line, so it's have a negative slope. So let me check on the y equal to -1/2 of x. So this is what we're looking for. Okay. Okay, so now we're gonna move up to let me just copy the picture for that. So now we're gonna move up to question number 5 and 6. So any questions regarding to um, the solutions. So let's say I want to find f of g, right? So we need to understand which one's out of function and which one in the function. So we're gonna get f of g of x. You're gonna rewrite that as f is gonna be the outer function. So g is gonna be the inner function. So this one's outer, this one's inner, right? So afterwards, so we know the fact that the inner function was radical x, the g of x. That's gonna be the inner function. So we're gonna rewrite this with f of radical x of x, right? So this one's going to be the inner function. So the inner function will be the input of the outer function. And that turns out we're going to plug into the outer function. So the outer function was x squared minus 5. So something with a square and minus 5 here. Okay. And then you just simply plug in radical x. So the radical x squared, they're going to cancel it out. And this is going to be x minus 5. So this one just x. Oops. Okay. Any question? Any concern?
No.
Okay. So now the same thing for that. If we look for G of F, and so the outer function is G, and then the inner function is F. So we just rewrite G of F here, and then just write up the G first. Okay. And then the G, so the F is the inner function, so we're gonna put the x squared minus 5. Right? So the f of x is going to be the inner function. So we put that g x squared minus 5. We plug that into the g of x function. So the g of x was square of x. So we simply just plug that in, x squared minus 5. So the domain of all of this, right? The domain of f of g depends on function f of x on 3 separate functions. F of x, g of x, and f of g of x. So when we find the domain of those functions, the first f of x, it's a parasitic from infinity to negative from negative infinity to positive infinity, but the g of x is greater than or equal to 0. Right? And for this function, you want to make sure that it's this one is also perfectly okay. So for that one is so this one just pass just for anything. So the joint interval for all of this basically from negative infinity. I'm sorry, from 0 to positive infinity. I apologize. So the 0 also inclusive. So we have to change to the um, parentheses to the bracket. So this one, so the reason why we have this greater equal to 0 because because that's coming from the radical x, so we have to be positive. But second one is harder because when you look at that, it's different. We have to go into that it's greater than 5. It's not 6. It should be 5. The solution. Okay, so this one should be 5. Okay, so you want to make sure this one is positive, right? X squared. So for the g of x, we need to go into that x squared minus 5 is positive. And then we also need to go into that it's radical x positive, so x positive. It's so hard for that. They just change a certain program function. Okay, so you're gonna solve for those two. You're gonna get from negative infinity to negative 5 and 5 to positive infinity. I think you only satisfy for the first part of it, like from radical 5 to positive infinity. I think you have to get rid of this. So now we need to know how to sketch the function. So you have to be done on a calculator. I think we did this question before, correct? So let me try to do it again. So for the x-intercept, so we want to make sure that we're gonna set so we're gonna set y equal to 0. So let me just pull out a calculator for this class. So we're gonna go to module. And let me just download it. First of all, that we need to plug in the function. So we have 2x minus 1 times the square root of 1 plus x. And then we're going to close parentheses, and then you're going to graph the function. So it's gonna go like this. Okay. For this particular function, we can set 2x minus 1 equal to 0. Okay. Because this is a multiplications, we can always do that. And 1 plus x equal to 0. So we can solve for that. We can get x equal to 1 half and x equal to negative 1. Okay. And this is how it looks like. Maybe you just change to negative 5. All right. And then afterwards, we want to find the y-intercept and the maximum and minimum of the graph. So let me just do the rest of the parts here. So for the y-intercept, we simply just plugged in x equals to 0, and then we just solve for y. So we have f of 0 equal to 2 times 0 minus 1 times the square root of 1 plus x, 1 plus 0, which is 1. So the whole thing just turned to negative 1. In order to find a maximum and then the minimum, so it's not quite easy. So you might go for trace, and then you're gonna go for the minimums here. So the left bow is here, and then the right bow was there. Let's see. Hold on a second. So we can really testify that so it doesn't really have a maximum, but it does have the minimum values. So it's no maximum, right? No max. So it's keep going forever. So the minimum value obtained at x equal to negative 0.5, right? And the y value would be, so the y equal to negative 1.414. So negative 1.414 in a calculator, that's close to the square root of 2. Okay. So we can literally check the domain, the domain of the function. The domain of a function is simply starting from the from this point from -1 to infinity, right? So it's any value that is smaller than -1 does not work. You can try -2. You plug that in, you're gonna get negative the square root of -1 for this function. So that doesn't work. And then the range of the function is starting from the minimum value. So the minimum is negative 1.414 to positive infinity. Okay. So determine the interval of the function that is increasing or decreasing. So remember the function going to be decreasing from -1 to to the interval that we have when it obtained the maximums here. So that'll be -1 to -0.5. Usually we have to use the parenthesis for this. So the function going to be decreasing. So it's just going downward. This one. So starting from negative 0.5 to infinity, the function increasing to us. We're going to use the parenthesis for that. The function increasing. So when you started from this part, from negative 0.5 to whatever it is, it keep going forever. So this one you're gonna be make the function. It's gonna make the function going up. So that'll be increasing. So now the last part we need to solve the inequality. So it's just simply we need to determine the range for x such that the function less than 0, right? Such that the y value less than 0. So the range for x that make the y value less than 0. So you need to find the domain of x such that the function is below the x-axis. Why is below the x-axis? Because less than 0, right? Less than 0. So that's below the x-axis. Okay. So we need to find a domain that the function's below the x-axis. So that's basically a thing. So we can literally check that the domain of the function that below x-axis will be starting from -1 to 0.5. Okay. So we're going to have this one equal to -1. And 0.5. Are we good? It's strictly less than, so we cannot use the bracket. We're gonna use parenthesis for that. So -1 and 0.5. So strictly less than 0. Are we good?
Yeah.
Okay, so I really want to go over that question as well because this is going to be on the test. And then, I mean, every single problem that we have here will be on the exams, but just in case that you have concern regarding to solving the system of linear equation, remember we have to include how to solve a radical equation, rational equation, absolute values. All of this will also be on the test. Okay. So when we want to solve the system, the linear system, so what we have to do, so we have to make sure that, I mean, we can use substitutions or elimination method, but make sure they have a same coefficient for both x or y. Okay. So that's the first part. So in this case, if they do not have the same coefficient, so we need to multiply by the entire equation with the different factor, right? So I can multiply the top equation by 2 and multiply the second equation by 3. The entire equation. So the entire equation meaning that, well, it have to be the entire equation, right? You cannot just multiply by a single entity so that, you just want to make that equal to. So when I multiply the entire equations by 2, I'm going to get this with ax minus 6y equal to 14. Okay. So now when I multiply the bottom by the entire, I multiply the bottom by -3 for the entire equations. We have -15x plus 6y equal to -42. So observe, the reason why I choose to multiply the top equation by 2, the bottom equation by 3, because I want to make them to have 6y at the end, right? So they both have, so both equation that's 6y. And then if they have the same coefficient, we either add or subtract them, right? Then we can proceed by add or subtracting. So let's say we're going to add them up. Okay, so we end up with what, people? So we end up with ay minus 15y. I'm sorry, ax minus 15x. So it's gonna give us 7x. And then afterwards, we add them up. Negative 6x, negative 6y plus 6y is 0y, 0. And 14 plus negative 42, I get this part equal to negative 28. Okay. In front of that should be negative 7x. And then we just get rid of the y. That's the main goal. So if we don't proceed this step, so you will not be able to get rid of the y variable. And what we have done is basically not really helpful. So now we just divide both sides by negative 7. And then we simply just solving for x in this case. So we're going to get x equal to 4. And afterward, we're going to choose either top, the second equation, or any equation that you have, and then choose one of the equations, plug into x. X equal to 4. So let's say I take the first one. So we're going to get 4 times x, which is 4 times 4, because x equal to 4 minus 3y equal to 7. Okay. And then we're going to get this one equal to 16 minus 3y. Equal to 7. So in the situations, we're going to subtract 16 both sides. So we're going to get negative 3y equal to 7 minus 16 is negative 9. So we get y equal to 3. Oh, you here? Make sure we note this questions will be on the test. And then you have to do more practice.
Okay.
Any question? Yeah?
No.
No.
Is it always going to be 2x and 3x?
No, it depends. Let's say we can't actually multiply this by 5 and the bottom by 4. It's just simply we're just watching the coefficient for top and the bottom equation, and then you just choose the number that you multiply them. So let's say I have the top is 3y, so I multiply bottom by 3. I have the bottom is 2y, just multiply top by 2. By doing so, I definitely going to get the common factor, so it's 6y at the end. We add them up, get rid of the y, and then we sum for x. Right? So remember, we need to get rid of one of the variables we call elimination method. So we also need to make sure we can eliminate one of the variable to proceed. If you can't get rid of one of these variables, we can't proceed further because you're going to get stuck there with both equations. So the whole reason why I can proceed that I can solve for x because there's no y involving it, right? So there's no y here. Negative 6y plus 6y 0. So no y. answers because there's no y. Are we good? Any question?
No.
All right then. You're gonna move up to the last part, the next part. I'm so sorry. So we need to solve the equation, the linear equation. I'm sorry. So first of all, we need to know that the slope of secant line is simply given by the m equal to we take y2 minus y1 over x2 minus x1. So for this particular questions, we should note that the linear equation basically given by y equal to mx plus b. M would be the slope. And b is going to be the y-intercept. So when I consider a certain problem like that, so we consider the x will be the number of years. And then the y's in this question would be expectancy, right? So the first x that we take into account was 1900. That gives 49.2 years. And then the y was 2000, is basically 100 years different. And then it's going to give 77.3. So we can get the slope, right? By taking a difference, y2 minus y1, so we take 77.3 minus 49.2 over 100, because that will be 100 years different. We're going to take 2000 minus 190. Are we good?
Yeah.
So you can do the math. So 77.3 minus 49.3, 49.2 over 100, I got 0.281. So this one is positive slope, right? It's positive. So meaning means that when x increase, y also increase. When x decrease, y also decreases. I'm sorry, x decrease, y also decreases. So we can interpret what it means by the slope. So for every years, life expectancy in the US increased by 0.281. By the equation, so we're going to have y equal to 0.281 of x plus b, right? So we have to solve for b in this case. So you plug in any value we have. So you plug in x equal to 1900 and y equal to 49.2. So we're going to get this equal to 0.281 times x was 1900 plus b. So multiply those two. And then you should be able to get it done. So we're going to take 0.281 times 1900. I got this equal to 533.9. Plus b. So we can solve for b by subtracting 533.9. We can get the b equal to 49.2 minus 533.9. So we have the answer with negative 484.7. So therefore, we can have the equation y equal to 0.81x minus 484.7. So the b is a 1 to set, right? Are we good?
Yes, we are.
Okay. So if you have any questions, just let me know. This is basically similar to finding the linear equations given by both 2 points, given by 2 points. So the first point will be 1949.2. The second point will be 2077.3. And then you need to fill in the blank the x should be the t's, and then the years, right? X is the years, and then the y is the expectancy. Okay. If I'm going too fast, I can slow it down a little bit, just making sure that we knew what it is. So now we're going to solve the last two. Oops, sorry. So what is the life expectancy at the year of 2020? So we can literally just plug that in. So we're gonna given by the x equal to 2020, x equal to 2020, and then we just simply plug that in to the equation. So we can have the y equal to 0.281 times 2020 minus 484.7, right? So let me change the marker a little bit, just making sure that we have different values here. So it give me 82.92. Okay. 82, I'm so sorry, 82.92. And then what do we expect it? And I'm sorry, how long, what will be the life expectancy reaches 90 years? We're just solving for x in this case, so we're going to get y equal to 0.281x minus 484.7, right? So what it means by that, so what happened if the y equal to 90 years? So we're going to have 90 equal to 0.281x minus 484.7, right? So when y equal to 90, what is the value of x? So we need to solve for x in this case. So we just need to solve for x. So we just plus 484.7 both sides. And then afterward, we divide both sides by 0.281. So we can have 90 plus 44.7. And then we divide both sides by 0.281. So I would say we're going to reach 90 years old life expectancy when we reach 2045. Okay. 0.19, something like that. It's like 20 years from today. More than 20 years from today. 21 years, I believe. How we go?
Yes.
Okay, so we just sum for x, we just add 484.7, the 1 to set, divide both sides by 0.281. All right, so if there's no more questions, let me just move forward. And for 9, 10. So for question 9, you need to make sure that 2x plus 5 positive, right? Is greater or equal to 0. Because it's a radical terms. So we want to make sure that 2x plus 5 is positive, and x squared minus 25 is not equal to 0. So the first one, we can solve it by solving for x. You're going to get x squared or equal to 5/2, negative 5/2. I'm so sorry. And this one, we just simply just plus 25 both sides and take the square root. You're going to get x is not equal to 5, negative 5. Over here. And then passing through the vertical line. So the vertical line always started with x, right? X equal to a. So we have to pick the point from x. So x equal to negative 2. If we change the question, let's say we change the question to horizontal line. Passing through the point, negative 2 and 7. So it's going to have the equation, which is what they have to start with the y when it's the horizontal line. So just y equal to 7. Just pick the points right here. All right, guys. So now we're going to move up to the decomposition of the functions. I'm not sure we went over that. So let me check. From last class that we go over, I'm not sure we did it, but let me just go back there and see. We started with linear function. The slope. Okay. So we need to find functions such that satisfy this. So we need to look for two function. Outer and inner function. Okay. So how can we do that? So the outside of it. So the outer function, basically the outside functions, right? Is the outside functions. Most likely followed by the square root, something like that, the key root, or 1 over something. Right? Something like that, or 4 over something. For these particular questions, so the outer function is f, right? So f is the outer function. The inner function, on the other hand, is something that inside of it. Inside of the outer function. One over something, it's 5 over something. So for the function that we have here, I think we're gonna move up to the next page. Oops, so sorry. So the f gonna be the outer function. So we observe that the outside of it have to be this it have to be the for root. And then we're gonna start it with for root of x. Okay. So g of x will be the inner function, So that doesn't include everything else. So in this case, the g of x is going to be x squared plus 4x. Okay. How we go? So when you combine them, so when you do like f of g, so you just plug that in into the inner function, and then we can check that it's gonna equal to h of x. How we go? Something. So the outer function, inner function is you always use the priority for the square root or x squared, something like that. And then you had to play along with, you know, x squared, x cubed, exponent, something like this. Okay. All right, so let's start it with question number 12. So I think we went over this questions many times, and this question also be the quiz question. So we're gonna skip this part. Just look for f of 2 plus h. You get something like that, and f of 2, you're gonna evaluate it, and then you take the ratio. So you're gonna have f of 2 plus h, which is h squared plus h minus 1, and f of 2 will be negative ones. And then you divide both sides by h. You cost out the 1, and then you factor out the h. You're gonna have h plus 1 at the end. So odd even function. So f of x will be even if they include all the exponent, right? The even exponent, including the constant and constant. Okay. So it's happy satisfy this property, which is f of negative x equal to f of x. So let's say I give you one example. F of x equal to like 4x to the 6 minus 2x squared plus 5. Okay. So this one's an even function. And f of x is odd function if it's include or odd exponents without constants, right? The constants basically considered an even function. So f of negative x equal to negative f of x. So we can take one example. You can have f of x equal to, let's say, negative 3 x to the 5 minus 4x cubed plus 2x. So let me just sketch the function and see how it looks like. So let's say for the even function, it's going to go like, it's going to be symmetrical. So we have what f of x equal to 4x to the 6. And then minus 2x squared plus 5. Okay. So the function will be symmetrical around the y-axis. Now we look at the odd function, f of x equal to negative 3x to the 5th minus 4x cubed plus x. Okay. So this would be called the odd function. So it doesn't really have to include any constant. If you include some constants, let's say it's no longer odd function. Okay. So this one going to be the odd function. It's going to be symmetrical around the x-axis. Okay. So now we can literally check. We can literally say that the function f of x equal to x squared minus 3x plus 1 is neither odd or nor even. The reason behind that because it's include exponent, the even exponents, and odd exponents. So this one even, this one's odd. So 3x to the 1 is odd exponent. So we don't count this. Are we good with that, people?
Yes.
So whenever you see like something x squared minus 3x plus 1, so look at that. Let me just hide this function. Okay, so now let's say we're going to look at that. Let me just hide this function. So we have of x equal to x squared minus 3x plus 1. So it's not symmetrical around the y-axis. So this either is neither not odd or even. So we can't literally say anything. Okay. So look at that one. You can like 4x doesn't matter, or 10x. So it still be symmetrical around the x-axis. So all the point gonna be reflects right upon the x-axis. Okay, you're gonna flip the entire curve. The same thing for the even functions. So let me just change that to like 5x is no longer symmetrical. Look at that. It's not going to be the same because like not odd or it's neither not odd or nor even. So if we just like -4 and make sure that this one is 6, it's gonna look better. This one is 1, right? You can't actually plus 2x to the 4. It doesn't matter, right? It's still be an even function. So symmetrical around the y-axis. All right, guys. So now we're gonna move to the last part. I'll let you go for sure after this one. We know how to sketch the function, but this piecewise function should be very difficult to draw. So the thing I'm not gonna include a graph. I just making sure that people know how to solve the question. So the first you have to do, you need to identify the endpoint. So I believe it's one of the things that we have to deal with. So piecewise function. So we need to identify the endpoint first. Okay. So the endpoint that we have will be -5, 1, and 5. Okay. So the domain of the function is simply from -5 to 5. Okay, so we're just starting from, so the domain is, so the starting point, the domain of the function is just starting from -5 to 5. The starting point should be -5 and and then to +5 in this case. It's really hard to find a range unless you know how to sketch it. Okay, so plug in the value. Plug in those point into the f of x function, right? Plug that in. So for those endpoint for -5 and 1, right? For those endpoints, -5 and 1, they belong to the first function. Square -2.
I am, but still. Huh?
I'm so sorry about that. Just I gotta mute it, but it's very noisy. And then so x squared -2 going to be like the function that we have to plug in those 2 points, right? It's -5 and 1, so that's going to be endpoint for that. So we're going to have to look for f of -5. So this one is going to plug that in. So -5 square -2. -5 square -2 is 25 -2 is 23. And then also we have to plug in the endpoint, which is f of 1. I'm definitely going to choose like a better endpoint for us to plug in on the test. And then you're going to have 1 square minus 2 is -1. And the function x squared minus 2 should go like this. Okay. It should go like that. So make sure the piecewise functions, like each domain will not violate each other. Okay. And then for those endpoints, one and five, right? So we know that 1 and 5 does belong to the function f of x equal to 2x minus 1. So remember, those are not including the equal sign, so we cannot set the equation equal to that. So we have to put like different, it's not equal to, but we need to use those point on the graph when you sketch it. So the same thing for that, we're going to do like f of 1. Plug that in. So 2 times 1 is minus 1 is 1. So this one inclusive, right? This point inclusive because we have the equal signs here. And then we also have f of 5. So now f of 5 is not inclusive. So 2 times 5 minus 1 is 9. All right, then when we sketch the function, you want to make sure that those are do not violate the each domain of the of each function. So between -5 to 1, so we have -5 to 1. So this is -5, this is 1. So that's going to be the function go like this, right? X squared minus 2. And from -5, from 1 to 5, so that would be another function, 2x minus 1. Okay, so now we might look for some optional point. Let's say instead of -5 to 1, you can also plug in 0 belong to the first function. So you can use it. You can just take f of 0. We're going to plug that in. So f of 0 will be 0 squared minus 2 is -2. I mean, there's no other reason for that. Just make it look better. So f of 0 is -2. Okay. And then the function f of 5 is 23. So we don't really have that point. So this one just keep on going forever. Okay. I never draw it perfectly on this. Are we good? And now this one have to be like an open circle because we don't count this point. And on the other hand, We're gonna starting. We have to start sketching a second function. So for x, forever one equal to one, so this is a equal to one as well. So this one is a close function to close that. And then phi is 9, so it's gonna be up here, something like this, but you don't necessarily have to do it. Right? So it's gonna keep on going forever, but this one have to be like the closed circle. And this one is open circle. Okay. Are we good?
Yes.
So let's grab the function first, right? So we're gonna, it's gonna be like y equal to so the value of x was bounded between -5 less than the x less than 1. So we had the function has the equation x squared minus 2. Okay. So we're gonna look at this point. So this is so we're gonna point out like a certain point that we did. The first one that we did was -5 to 23, right? So when x equal to -5, y equal to 23. So remember, this one is an open circle, right? Open circle. Make sure that we don't close it. Open circle point is inclusive. I'm sorry, exclusive. We don't count this because the sign was less than, strictly less than -5. I'm sorry, greater than -5. So now we're gonna go to another one. Another point will be this is the minimum that we have 0 to -2. So this is the minimum point. So we have to utilize that to identify the range. And then afterwards, when you plug in x squared when we plug in x squared -1 -2, when x equal to 1, we end up with 1 and -1. So that's also open circle. Are we good? So this one open circle. And finally, that we're going to have this another function, which is y equal to from 1 less than equal to x less than 5, right? We have the function 2x minus 1. And of course, we need to label the points when x equal to 1, y equal to 1. So this one is a closed circle. And then when we label the points when x equal to 5, y equal to 9, so this one is open circle. Are we good? The only point that we inclusive because x is greater or equal to 1, so we have an equal sign here, so we have to take that as a closed circle. Any question? Any concern?
No, no questions.
All right, then. So this is what it looks like. So let me just answer the last part of the question, and I'll let you go. Find a range, right? So the f ranges depends on the minimum value. So So since the function has the minimum at x equal to x equal to 0, y equal to -2. So we're going to start off with the range of that. So the range will be from -2 to infinity. All right, guys. So now afterward, I'm going to go over we're going to go over so please go over
I did.
please go over the radical equation. Okay. Rational equation. That's going to be on the test. Absolute value inequality, absolute value inequality. Okay. So and then quadratic equation with the complex root. Okay, so the exam going to be on Thursday. Exams one's going to be on Thursday one more times. So you can bring a page of notes. Okay, so you can bring a page of notes. Make sure that you have a calculator with you, right? So calculators. And pen and pencil. All right, guys. So I feel like that's pretty much it. And then the exam should start it at 3:30 p.m. to 6 p.m. Okay. Let me know if you have any questions, any concern. Okay.
I have one.
Yes.
I wanted to know if it is possible to use a vertical line test in a piecewise functions.
Piecewise function.
Yeah.
Yes. So you can use any vertical line test. So it's still your function. Remember, one point may be inclusive. So we cannot have like 1x. We have two different y values. So which is why I state this is open circle, this is closed circle, so it's not inclusive when x equal to 1 right here. Yeah, it still be a function. The piecewise function still be a function.
But what about the gaps that some piecewise functions have?
Yeah,
They
so
are defined in some x values.
it's perfectly okay. So let's say we're gonna start off to -1 instead of 0. I'm sorry, uh maybe 0.5, something like that. So you might have a little gap right here. That's perfectly okay because the function doesn't have any restriction that you have to fill up every single gap on the domain. You might have a certain undefined domains right here in the situations. So we have the function will not be defined between 0.5 and 1 because when you draw a vertical line, it doesn't meet any point on the function, right? So when you draw a vertical line, so the function would be undefined from 0.5 to 1, but that's perfectly all right. As long as that when you draw a line, it doesn't cut the function at 2 point, then we should be good.
Okay, thank you.
You're very welcome. So like I said, the function is perfectly a function, but if you have something like this, if you violate it, so instead of from -5 to 1, you're gonna get -5 to 2, for instance. So now this is not a function. This is not a piecewise function. Why is that? Because I draw a vertical line between 1 and 2. What happens? So it's going to meet the function at 2 points, correct? So when it meets the function at two different distinct y values, this is not the function. Okay, obviously this is not a function. So in other words, the domain cannot violate another function domain. You might have less of the points, but we shouldn't have more.
Okay,
Great.
thank you.
You're very welcome. So I hope that it's really helpful. And then when it comes to the exam, make sure that you're going to bring a page of notes and a calculator if you can. And also, I prefer if we just go back to the notes right here, the first few lectures that we did. We're solving the yeah, this one is going to be on the test. Like I said, something like 25th, right? Look at that question. Like a few notes. Like this question is gonna be on the exam, so we need to know how to solve it. Quadratic form, like different quadratic forms. And um, please study on it. So lecture note. You should be good. You should be good on a test. And let's say we solve the rational equation as well. It's one of the things very difficult, right? Square root, absolute values, and stuff like that. All right, then I'll see you. Let me take attendance real quick. We have 12 people, right? And let me just look for the names. Samantha is here?
Yep, I'm here.
Yeah, I mark everyone at present first. And I believe we have 13 people. And let's see if anyone who's not here. So I think that's pretty good for today. All right, so have a wonderful day. I will see you guys on Thursday. Prepare for the exam. Take care.
Thank you.
Thank you.
Thank
Thank
you.
you.